Good morning. I haven't had the best of luck this morning. It took me like 3 hours to get a video posted for first period normal algebra 2 classes. So hopefully I've got all that worked out by now for y'all. Uh, we're going to start off calculus by going over trig. So, you got that to look forward to. And we're going to start off today with unit circle. That's where I'm going to start. You might remember that from algebra 2. I don't know. First thing, I'm under quarantine till at least Thursday. So if I get back Thursday, the first thing we're going to do in this class Thursday is you're going to take a unit circle quiz. When you were in Algebra 2, I already had the unit circle drawn for you, blanks and stuff like that. Not going to do it for you. So just draw the circle. You don't really have any homework tonight, but what I would do is I'd practice this thing until I had it down. I memorized it 25 years ago, so it's still there. So, take some notes and pay attention. Unit circle is built on two very special triangles. First special triangle that the unit circle is built on is actually what we call a 30, 60, 90 special right. I don't know if you remember this or not, but on a 30, 60, 90 special right triangle, which I don't have drawn properly because I had the long side across from a small angle. So let me redraw that. This should be the 60-degree angle, and that should be the 30. But on a 30, 60, 90, the hypotenuse has a length of 2 normally. But when we talking about the unit circle, we need things to be in terms of 1 because the unit circle has a radius of 1. So we call the hypotenuse 1. According to 30, 60, 90 theorem, the short leg is half the hypotenuse, and the long leg is the short leg times the square root of 3. So it becomes root of 3 over 2. Now the other special right triangle we're going to need is a 45, 45, 90. If you remember anything from geometry, the congruent angles imply a pair of congruent sides. Now these triangles are going to be overlaid on a circle where the hypotenuse is the radius of the circle, so the hypotenuse still has to be 1. Deal is to go from a hypotenuse to a short leg on a 45, 45, 90, we divide by the root of 2. And that's just an ugly looking number. So to make it look prettier, we multiply the top and bottom by the root of 2 over 2, and we get a root of 2 over root of 2 times root of 2, 2. So there's the legs of these things. Root of 2 over 2 and root of 2 over 2. All right, now I'm going to freehand draw a circle. I'm doing pen, so I cannot mess it up. And there's my circle. I'm going to overlay that circle on the XY axis. And then I'm going to start thinking about angles. This point right here, if you remember anything from Algebra 2, when angles are drawn on the XY axis, it's about the measure of rotation from the positive x-axis. So if I just place a point here, it's actually a straight angle, but there has been no rotation, so it measures 0 degrees. Now, another thing from Algebra 2 that you need to be remembering is pi radians. 0 degrees is equivalent to 0 pi. And if one was to travel full circle, go all the way around the circle, you would cover 360 degrees. And 360 degrees is equivalent to 2 pi. Now, I realize that radians is probably a little bit forgotten by now. But, say you have a 30-degree angle. If you want to convert that into a pi radian, what you do is you multiply it by pi over 180. Now the degree symbols cancel. You're left with 30 pi over 180. And 30 over 180 is 1 over 6. So a sixth of pi, or we say pi over 6. Now the reason I went ahead and used 30-degree angle is because that's the next angle I'm going to be talking about. 30-degree angle, 30 degrees rotation is probably about right here, pretty close to it. So there's a 30-degree angle. It is equivalent, and I'm putting these in the wrong spot, but it is equivalent to pi over 6. Now, what matters a lot here is the coordinates of this point. There is an x and a y value at that point. Now, I don't want to mess up my circle here, but imagine that I take this 30, 60, 90 triangle and I just kind of lay it right here. Okay, I lay that hypotenuse, so the hypotenuse is here, the short leg is here. Well, to get to this point, I have to travel to the right a root of 3 over 2, and I have to travel up half a unit. So there's the coordinates at that point. Next thing on a next angle of interest is going to be 45 degrees. 45 degrees is equivalent to the pi radian, pi over 4. And I kind of use the same idea as before. I think about this special right triangle drawn or overlaid onto this unit circle. Well, this would be the hypotenuse right here. And these two lengths would be the legs. It turns out both the legs are root of 2 over 2. So there's my x and y value respectively. Next angle of interest would be 60 degrees. Now, same deal. Take your 30, 60, 90. Think about it being overlaid right here. You would travel to the right half a unit, and you would travel up a root of 3 over 2. And congratulations, you just completed quadrant 1 of the unit circle. This angle right here, if we think about rotation, is a 90-degree rotation. 90 degrees is equivalent to pi over 2. And if you just think about the ordered pair, okay, to get to this point, we did not run right, we did not run left. So the x value is 0. And this is called a unit circle. Unit circle is a radius of 1. So we just traveled up a unit. So there's your ordered pair. Now, the rest of this is actually pretty simple. You know, I would do the degrees. You know, the next angle of interest is 120 degrees. Look at the separation here. That's 30 degrees. We're going to move 30 degrees here. Look at the separation here. That's 15. Okay, so we add 15. That's 135. 15 separation here. That's going to be what, 150? 30 degrees of separation down here. That's 180 degrees. And you just think about your separation as you go around. So the next guy up here would be 210. We add 15, we're sitting at 225. We add 15 more, we're sitting at 240. And then we're down here. These spots may not be in the exact location, but they're close enough. 270 degrees. And seems like we add 30 to get to 300. We add 15 to get to 315, and we add 15 to get to 330 degrees. So there's the angles. You know, don't be that kid who can't even get the angles right. You're in calculus. Like, if you can't do the angles, what are you doing in calc, kids? Now for pi radians. There's a lot of ways of doing this. I see 120 as twice as 60. And for some reason, I never mentioned the pi radian of 60. It's a pi over 3, because 60 degrees is a third of 180, pi being worth 180. So if 120 degrees is twice 60 degrees, then the radian measure has to be twice pi over 3. Well, that's going to be 2 pi over 3. 135, I kind of glance back at 45. 135 is 3 times 45, so 3 times pi over 4 being 3 pi over 4. 150 would be 5 30s. It'd be 5 pi over 6. 180 is pi. I mean, that's just the way it is. Pi is equivalent to 180 degrees. Now, for the rest of these, if I had a nice pretty unit circle, this would be more obvious. But you can kind of do what I've been doing. You know, 2 tens is 7 times 30, so 7 pi over 6. Maybe you remember from Algebra 2, what I used to tell you to do was look across the diagonal. Look across the diagonal here. So there is an understood 1 in front of that pi. 1 plus 6 is 7. Still sitting over a 6. Okay? 225, look across that diagonal. There's a 1 in front of pi. 1 plus 4 is 5. 5 pi over 4. Or you can sit here and think about 5 times 45 being 225. 240, look across that diagonal at 60. Okay? 1 plus 3 is 4. 4 pi over 3. 270, which is 3 pi over 2, but you can do the diagonal trick. 1 plus 2 is 3. There you go. 300. 300 is going to require you to look across the diagonal as well. So you look across the diagonal at 120. 2 plus 3 is 5, kids. 5 pi over 3. Now, it works better if you memorize these things as opposed to using a little trick like that. And hopefully you do. 315, look across the diagonal. 3 and 4 makes 7. 7 pi over 4. 330, check across that diagonal again. If you hadn't heard me say that a half dozen times, 5 and 6 makes 11. So 11 pi over 6. And that's the issue that most kids had. Most kids actually had an issue with the radians back in Algebra 2. It's always been that way. It's the radian measure because you're not that comfortable or used to working with radian measure. Now, the only last thing we got to do is we got to finish off all these xy values. All these xy values. Well, that's easy, you know. These two angles share the same point. To get here, I ran 1 unit right, and I didn't go up or down, so 1, 0. Points like this up here, I like to use symmetry, you know. Just look directly across, use symmetry. Ideas of equidistant, okay? Now, I actually went to the left to get here, so instead of being positive 1/2, I'm negative 1/2. But I still went up. That's root of 3 over 2 all day long. So 135, I use symmetry, even though it doesn't look like it on mine, with 45. And I went backwards, so negative, still going up. 150 has symmetry with 30. I went backwards, so negative root of 3 over 2, but I still went up. You know, over here, this is what we call a quadrantal angle. I went back 1, but I didn't rise anything. 210, I would look across that diagonal, look at the ordered pair, use a little common sense. We went left and down, so both signs are negative. Same thing with 225, look across that diagonal. You went left and down, so both negative. 240 across that diagonal. You know, when I was a kid your age, I had to do little stuff like this too, but I did stick it long-term memory. I don't need the drawing anymore. And I suggest you try to get that point too. You know, if you're an engineering major. If you're an engineering major and you don't have the unit circle memorized, you may as well go get a fine arts degree because that's what you're getting because you're in the wrong thing. Anyways, down here, no left, right, fell. You can use symmetry either above, across the diagonal, or, you know, to the left. It's really up to you. But, and you can also kind of use appearance here. I mean, it looks to me like you went right about a half a unit down a root of 3 over 2. Maybe you'll get that, maybe you won't. 315, kind of ran out of room here, but it's root of 2 over 2 and negative root of 2 over 2 because you're falling. And 330 runs to the right pretty good, so root of 3 over 2, and you fell a half a unit. And there's the unit circle, kids. So the next time I see you, which I hope is Thursday, you're going to take a quiz on this thing. We got a little more to add to it, but memorize this thing. Get it down, memorize it. Tomorrow I'll probably teach a little bit of a lesson about how to use it. But for tomorrow's lesson and for the quiz, what you also have to go back is you have to know a couple of things here. The sine of some angle on the unit circle is the y-coordinate. The cosine of some angle, if that angle lies on the unit circle, let me zoom in there and clear it up, is the x-coordinate. Does anybody remember how you find tangent? You know, Julie, Elizabeth, Zach, Maddox, Carolyn? Anybody remember? Tangent, there's a trig identity, and I know we talked about it. I remember talking about it with your group. It says tangent is the sine of some angle divided by the cosine of some angle. So it's just y over x. And there's the unit circle, kids. What I'm going to want to see from you on a quiz is this entire sheet of paper. Okay? You know, obviously you don't have to worry about this, but I'm going to want to see both special right triangles. I'm going to want to see all the angles in both degrees and radians, and I'm going to want to see the x and y values. And as you practice these, try and lay it out better than I did, because I didn't do the best job. But I'm going to zoom out so you maybe take a screenshot or whatever you want to do. There's the unit circle in all her glory. And that's it for the day. I think, depending on how test results come back, I should be back Thursday. I really hope I am. But if I'm not, who knows? Anyways, y'all have a good day.